This is question 5 from section 1 of the 2018 NSAA paper. So in this question, we're given a scenario where we're selling water bottles per day, and we're told the expected number of water bottles sold in a day is directly proportional to the square of the temperature, specifically in degrees C. And you can implicitly assume here on temperature above 0. So we're told on one day, 64 bottles are sold at 16 degrees C. And we're told this is the expected number of bottles for that temperature. And then we're given another day. On a day of T degrees C, 256 bottles are sold. 31 more than the expected value. And from this, we're asked to find T. So we've got all this, and it's very wordy and messy. Let's try and write it down algebraically. So let's call E the expected number of bottles generally, and T be the temperature on that given day. These aren't fixed in any way, these are just general variables. Because what we can write is number of water bottles directly proportional to the square of the temperature, we can then notate as this. Which is nice because we've converted this horrible wordy stuff into algebra. So if E is proportional to T squared, it means E is equal to KT squared, where K is some constant. So clearly now we'd like to work out K. We've got two pieces of information to try and do that, but considering we don't know the temperature here, to work out K I think we're going to have to use this piece. So 64 bottles, so E is 64 and T equals 12. So 64 must equal K times 16 squared. But then divide through by the 16 squared, which is 256. And 64 over 256, that's lovely, that's just a quarter. Because 60 times 4 is 240, 4 times 4 is 16, add them together. So this is a quarter. And we're in a much better state now because we can write this relationship down explicitly. So we know this expression's true. And we've got to utilise this to find T. So essentially we need to somehow substitute this information into here. So we know something's going to be equal to a quarter T squared. And we just need the expected value for this day of bottles sold given the temperature T. But we know 256 bottles are sold. And that's 31 more than expected, right? So we do 256 minus 31. That must be equal to a quarter T squared, i.e. the expected number sold. And this is an expression involving T squared. If we solve this, we're done. So this is 225, and that's equal to a quarter T squared. Let's isolate T squared, so times through by the 4 to get 900 is equal to T squared. And we want to take the square root here, which initially for most numbers this would be pretty awful, but you notice that 900 is 30 squared, as you can note, because 3 squared is 9, so 30 squared will be 900, and so T must equal 30. And that matches option C, and so our answer is C.